Hello and welcome to stock price prediction using recurrent neural networks. Stock price prediction is one of the most important and one of the most interesting problems, and it particularly falls under sequence modeling. Why sequence modeling? Actually, the prices of the stock, they have trends then that actually go back in time, and going back in time and seeing those trends and following those trends, one may try to predict the prices of the stocks for the next day or for the next couple of days or for next several days. It turns out these patterns that are in time, that are there in data, the data that is already recorded for stock prices, the real data, it turns out that those kind of patterns, they are sometimes really hard to grasp. And those patterns might have chunks, sometimes known as seasonal patterns, or maybe knowing just the most recent prices in the past, just the very recent prices in the past may not fulfill the accurate prediction criteria for the next day or for the future. And it is important because if we can have a software, if we can have a model that can predict the price for, let's say, next day, given the stock price data for several previous days, or the stock price data till the current day, then based on the accuracy of prediction, one may come up with the decision whether to hold a stock, whether to buy a stock, whether to sell a stock, and so on. Because the prediction of the price, if that is accurate, then accurate decisions about the stock can be made to actually maximize the profit. But it turns out that this prediction, finding out this prediction, even writing software for these predictions is not so easy. And if, for example, just hypothetically think, if, for example, writing a stock price predictor is that easy and that stable and accurate, then everybody these days may have, for example, a stock price predictor and may be playing with a lot of money today. But it turns out with the recent invention of more sophisticated models for sequence modeling, such as recurrent neural networks, it turns out that the bars for accuracy for stock price prediction are raised really high. And in this particular video, we are going to actually implement one such model for predicting the stock price on real data. And we will be using recurrent neural network. For the problem at hand, we will be actually modeling a problem in a way that we will be predicting the price for the very next day, given the prices for all the day till today. But then I will give you pointers, some intuitions, how can we modify our basic recurrent neural network model to actually handle, to predict for several days in future, or for a long time in future, rather than just for the very next day. So let's dive in and see some of the real data, how the data looks like, what are the attributes, and let's see some real patterns, and then we will go to Python. Actually, we will be using TensorFlow to implement recurrent neural network. So let's dive in. First of all, let me show you some of the data for a particular stock, that is HPQ.US data. This is from US. This is the date column. So for every date, we have an opening price for a stock. For that date, what was the highest price that the stock actually achieved? What was the lowest price for that date? And what was the price at the closing time? At what price the market actually closed? And then for the next day, for the same stock, what was the opening price, and so on. As you can see, the opening price for example, this day is this, and for this particular day, it's exactly the same. But then the opening price for the same stock, it actually changes. And not only that, you can see for example, you can see for this particular row, you can see that the opening price and the highest price, they are exactly the same. The opening price and the highest price that at that day the stock gained, they are same. But then that particular stock go lower to a lower value, and it actually closes at that particular value. So it looks like that the stock actually opens at the highest price and then it gradually lower down and stuff like so. But at the very next day, it actually starts trading at this particular price, and it maintains the price throughout and closes there, and so on. I'm showing you just the data for 1970s and just showing a few of the data. Let me actually show you the file that from which I took that data. That is actually this particular file, hpq.us.txt, and this particular file actually contains the stock price data. Just focus on this open, high, low, and close, and just do not focus on this volume and open integer kind of attributes. And this particular file that we will be, this is by the way real data, and the data it contains is from 1970s to 2017. So a lot of data is available. So so basically that's the data, and one might be interested in, for example, given the opening values for a stock for a long period of time, one may want to predict the opening price for the next day, or maybe the same for high price and low price or close price, or maybe given all the opening, high, low, and close prices for a long period of time in past. Let's say somebody want to predict the open price for the next day, highest price for the next day, lowest price for the next day, and close price for the next day. So this problem really is given a lot of values. Let's say a lot of these values. So given a lot of these values, let's predict, for example, all these values are the opening values for different dates. Let's predict the value for the opening value for the next day. So that's the problem, just focusing on, let's say, the opening price for now. So here is the real trend of the data set that I've just shown you here. In 1970s, the opening price for this particular stock actually stays like this, and then it got raised and then raised, but more or less at this particular time period till here, it looks like the stock price doesn't get raised very much, and actually this is a lot of years. For example, if you see 1970 to 1991, probably it's about 20 years, and the stock just more or less stays the same. I mean, there's a particular band over which it oscillates, and the band height is not that large. But then an interesting area for this particular interesting time zone for this particular stock is from 1991, if you can see, to 2001 here. So if you see in this particular bar, the stock price actually gained a very high value, and then actually drops down to a small value, and that area is also not very long in terms of the area in the initial phase. It actually goes to around 10 years, and then you can see the trend of this stock from 2001 onwards. It's actually somewhere go high, then go low, then go high, then go low, then go high, then go low, and then go high, and so on. So this kind of pattern, so it's a complicated pattern. One really want to know, for example, what will be the next value tomorrow? What will be the opening value tomorrow for this particular stock, given all the values from 1970s till today? So that's a problem. How can we solve that problem? So first of all, let's model this problem as a supervised learning problem. So for example, given the data for, let's say, x0 or maybe x1, which is the opening price for the very first day, let's say 1970, the first day, then x2, then x3, dot dot dot, x I somewhere, then xi plus 1, dot 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 dot, somewhere xt, and till today, let's say whatever the index in terms of days from the very first day, whatever the index that appears to be. So let me write today. So how can we, so this is a lot of data. How can we model this problem as a supervised learning problem? So let me give you one pointer. So maybe we can model this problem as a window fashion way. Maybe we decide a particular window to see the history and predict the pattern. For example, let's say the window size is, let's say 100. What we will do is we will pick the first 100 words, first 100 values, and then let's say this is, let's say the I here is 101. So let's pick the first 100 values and predict this value. So this particular vector of values, a sequence of values, x1, x2, dot dot dot, x100 will become first observation, and this will become first target, 101. That will be our target. So that's the first pair of inputs in terms of supervised learning paradigm. This will be this vector or this sequence of numbers, or maybe written as a vector, is the input, and this is the target. Similarly, if we just shift the window 1 or 2 pixels, actually I'm using the word pixels because normally this kind of operation is more common in images, sometimes known as very similar to convolutions. But anyways, if you shift your window 1 position right, then you can get another training sample, which is x2, x3, dot 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 to 101. That's your training sample, and your target sample for this particular training sample, your target for this sample is x102. And similarly, you can move 1 position onwards and thereby producing a lot of training samples and their corresponding targets. It turns out if you can build a model for this training data, the model will actually capture the pattern for last, let's say 100 days, and it will predict the pattern for the next day. And this model will be capable of predicting the value of today if the values of previous 100 days is applied to it. That it looks like a very simple model, and we are going to actually implement this model using recurrent neural network in this particular video. So the model we are going to use basically has this particular structure. So just thinking about the very first training sample, so we'll be having a recurrent neural network layer. X1 will be going in, and then something will be produced. Then X2 will be going in, and the output of X1 will also be going into the model, and something will be produced, and that something will also be going in, and then X3 dot 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 up to X100, and then X100 will finally produce Y hat, which should be equal to that, and there should be a loss function. We will define a mean squared error loss for this kind of problem. Let's implement this problem using a recurrent layer, maybe in LSTM, which is a very famous recurrent neural network model for handling vanishing gradient problem very well. And one other equivalent model, which is known as the GRU, gated recurrent unit, that is more recent, more simplified, but I mean the concept is more or less the same. A lot of similarities are there. So let's model this problem, and after actually solving this problem, I'll give you some pointers. How can we solve this? How can we upgrade our implementation and model that not only look into just one step ahead, but look several steps ahead, sometimes known as looking far into the future. So let's actually code. Let's actually prepare our data in the form we need for this particular problem, and let's implement and evaluate our model using recurrent neural network, using either LSTM or GRU, or stacking one over the other. And then let's evaluate our model, and then we'll come back to give you some pointers. How can we actually extend our model to look into very far in the future? So let's see. Right now we will just be predicting the next day, just one day. So first of all, let's import some libraries. Pandas as PD for this package is required for sometimes for example, this reading the data and stuff like so from files. Import numpy as np. This is required for array handling and data manipulation very quickly. It's almost always the default library for working in data science. And import matplotlib sometimes for visualizations, just in case if you need to see some graphs to understand the data even better. So first of all, let's pick the path of the file, path to file. That is, let's see, what's the path of the file? Here is the path of the file. So let's pick that. H, Control C. And then let's move back to that is R for the raw string. That's the path of the file. So, and now let's read this data frame. So as a data frame. So pd.read CSV, and we give the path of the file in it. We give a delimiter here. The delimiter is comma in our case, as can be seen in the file. If you go to the file, all the entries, they are separated by commas. Different entries, they are separated by commas. And then we can give what columns to pick. So for example, we can give use columns, use calls, and here we give just pick the date column, for example, and pick the open column, pick for example the high column, and pick close. Maybe one of these or all of these we are interested in. So that's our data. So let's look into the data, how it looks like. So this is our data. These are just first 5 rows of the data, and this is exactly the data. This is exactly the table that I've shown you in the slides. Next, what we do is let's plot the data and see, for example, what are the different kind of what is the pattern? Let's see the pattern for open values, which is the data frame. This is kind of the column that is there for it is indexed by open, or yeah. So let's see the trend for this. Let me just plt.figure. Maybe the size is 18 by 9 or something else, and then plt.plot df.shape, that is 0, which is the total number of records, which is the x value, and then actually we see how many are there. So range, these are our x values just from 0 to that, and then y values are data frame indexed by open. So let's plot these, and then we can plot, for example, the dates here if you really want. plt.x ticks range. Maybe we take a jump of 500 or something, 0, whatever the shape, whatever the length of, whatever the total number of records are, just take the jump of 500, and then just pick the corresponding date. So df update, pick that one, dot locate every 500 entry. So yeah, and maybe we want to set certain rotations, so rotations is equal to 45 degree. Yeah, so if we just do that, it will throw an error. Okay, what's that error? Let me see. Maybe there is some spelling mistake or something like that. So PLT figure, oh, I missed figure size here. I must mention the figure size in a tuple. So fig size equals to this tuple. Yeah, this tuple. And let me close that, and things should work now. Yeah, so that's exactly the plot that we saw in our slides. And this is basically the trend of the opening prices from 1970s to 2017. So that's it for the first part of this video series. In this particular part, we analyze the data, we understand the problem, and most importantly, we actually transform our problem into a single target regression problem. In the next part of this video series, which is the final part of this video series, we will be actually implementing this stock price prediction as a single target regression model using recurrent neural network modules, LSTMs and GRUs, and stacking them one another. And we will be doing that all that stuff in TensorFlow. So hope to see you in the next part of this video series, in which we will be implementing stock price prediction on the same data set using recurrent neural networks in TensorFlow. Hope to see you next time.